Maris, let me know if you can hear me.
I was
Hey, Maris.
something happened with the connection.
No problem.
Yeah.
So I was trying to ask you about prime factors. It sounded like maybe you already knew what to do here. Is just that's where we left off. So the first prime factor is 2. Prime number is 2, then 3, then 5, then 7. We may not need to go much past that, but you start with the first prime number 2, and you figure out 2 times what number gets you back to 8, and that's 4. 2, and then you try 2 again. And so that's why I was asking if you'd seen this in class, because there's another way I can show you that builds into this, but maybe we can try this. So from here, sorry about that, all kinds of issues. From here, you circle pairs. See how there's a pair of 2s?
Yeah.
So you're going to bring a 2 out. You're going to bring a 2 out. Okay. And then anything that's not a pair, you're going to leave in. So you're going to, that 2 is going to be in. So your answer has a part that's both out, and then a part that's in. So for this problem, the part that's out is the 2, and the part that's in is yet another 2. Now we're going to do a bunch more examples, but I hope this is something that you've seen in class a little bit.
Yeah.
Let me know when you get all this down. We'll move to example 4, 5.
All right, I got it.
All right, so you do the same thing here. You always start with 2. You ask yourself, well, does 2 go into 24? And it does. 2 times 12. Then you try 2 again. Does 2 go into 12? Yeah, 2 times 6, and then you try 2 again, and you get 2 and 3. And you look for pairs. Okay, so there's a pair of 2s here, pair of 2s, so a 2 is going to come out. The numbers that are not pairs, they stay in. So, maybe the analogy here is to socks. I like to pair up my socks, maybe, but not everyone does these days. But the pairs have to come out. And the ones that don't pair up, well, we just leave those off to the side. Okay, so your answer here is 2, the 2 you're bringing out, square root of the things that you leave inside, which is 2 times 3. And so anything that doesn't come out stays in or under the root. And then you simplify by multiplying those numbers under the root. Any questions on that before we move to another example?
No.
Okay. I would like to do a few more examples than what they have here, but we'll see if time permits for that. So again, you start with your prime numbers. Your prime numbers are 2, 3, and so on. We're just going to start with 2. Can 2 go into 80, or what is 80 divided by 2?
40.
40. And then you try it again. You try something until it doesn't work. So that's 20, 2 and 10, 2 and 5. So this time you have 2 pairs. You have a pair of 2s, and then you have another pair of 2s. So for each pair, you bring that number out. And the 5's left over, so it stays in. So your numbers, I should have said this earlier, the number on the outside are all prime numbers. And that's how you know when you're done, because they're all prime. So your answer will be 2 times 2. Oops, I get the wrong color here. That's probably not good. 2 times 2, because of the 2's you brought out, square root of whatever stays in, which is the 5. So we've got 4 square root 5 as your final answer.
Okay.
All right, so I guess we'll do number 7. Actually, this is one maybe you could try on your own and just see if maybe ask some questions along the way.
All right. I got 4 times square root of 2.
I didn't hear the outside number. What was the outside number?
4.
4 square root 2. Yes.
Yeah.
Perfect. Okay. Do you want me to give you more examples like this, or move on to the next set of problems? Because things kind of change a little bit here.
Let's move on to the next set.
Okay. All right, so EX8 here looks different. There's properties of square roots, and one of the properties is the square root of A divided by B is the square root of A times the square root of B. Basically, you can take the square root of the top and the bottom number. And in this case, the top number is prime, so there's actually nothing else that you can get. You can't reduce this any further, but the bottom number you can. Okay, what is this reduced to?
4.
4. So it's the square root of 7 divided by 4. And that's
That's
your
it?
final answer. That's it. Yeah. Now, it's leading up to some other problems where you will have to do more reducing. So I actually think we should go to 14, 15, and 16 next. They're the natural continuation of these, and then we'll come back to the other ones. Okay. So let me snip 14 in here. So let's just say here's where 14 came from. It was the square root of 25 over 2. And this becomes the square root of 25 over the square root of 2. And the square root of 25 is 5. Okay, that number is 5. The bottom you can't reduce. Now, this new word that you're about to see is called rationalize. And that means to eliminate the roots on the bottom. Okay, and you probably for sure wondering, how to do that. So you do that by multiplying the top and bottom by the same square root. So in the numerator here, it becomes 5 times the square root of 2, but on the bottom, it's now the square root of 4. So the basis for that is the square root of a times the square root of b is the square root of a times b. So now, what is the square root of 4?
2.
2. So this becomes 5 square root of 2 over 2. So we're gonna try another one here. And this will be just my own example. Let's say it's 6 over the square root of 3, and it says to rationalize this. You would multiply the top and bottom by the square root of 3. Now on the top, like what you cannot do is you can't combine the 6 and 3. It's 6 square root 3. On the bottom, it's the square root of 9. What does that become?
3.
Yeah, so it's 6 square root of 3 over 3. And then this time you actually can go a bit further. You can reduce because you can divide the 6 and the 3. So that becomes 2 square root 3. Is that okay?
Yeah.
All right, so now the next problem, 15, is a little bit different, okay? It's kind of like ones we did earlier. So you start out by breaking this apart into the square root of 7 over the square root of 3.
All right. There's a little bit of a problem with that.
Yeah, so you can't have a square root on the bottom, so you're going to multiply the top and bottom by the square root of 3. Now what's different now is this, the top becomes the square root of 21 because you multiplied them.
Yeah.
But on the bottom it becomes just 3.
Okay.
All right, so 16 is kind of related to the last two. They're not really giving you any same examples of the problem sets, but they're all kind of the extensions of it. So in 16, the issue is the square root on the bottom. So again, you multiply by the square root of 5 on the bottom. Okay, so this is 3 square root 10 on top. And then it's 5 on the bottom. And again, I'll point this out is the only thing you can reduce is what's outside the root. You can't reduce inside the root. That's not allowed.
All right.
Any questions on that before we move back to kind of this middle grouping of problems, starting with 9?
No, it's all good.
I guess we should have done 9 already, but anyway, we will. So this one is kind of like one we've already done. You're going to look at the part under the root first, the square root of 24, and you're just going to simplify that. Okay. So don't worry about the 5. The 5 is just going to come with, I want you to reduce the square root of 24. Let me know if you have any questions on this one.
Yeah, 2 times the square root of 6.
That is correct. So this part is 2 times the square root of 6. You pair it up with the other part, and then you multiply the outside numbers, 10 square root 6.
Yeah.
So if that made sense, try number 10 on your own here. We'll see what let me know what you come up with.
All right. We got 4 times square root of 2.
For the square root of 32, is that right?
Yeah.
Okay, so you have to use that 6 and multiply your answer by 6. What would be the final result of that?
The 24 to the square root of 2.
24 times the square root of 2. Perfect. All right. Really good. Really, really good. Okay, so let's go to the next one here, the number example 11. So they're increasing the difficulty by adding variables to powers, but really we're going to make it similar to what we've already seen. Okay, so there's a property of square roots that a times b becomes the square root of a times the square root of b. So this problem here on the left becomes the square root of 64 times the square root of x to the 6th. Now you already know how to reduce the one on the left. So you can always first go to your calculator and just try the square root of 64.
That's 8.
And maybe it works, maybe it doesn't. If it doesn't work, you then have to use the reducing method we talked about.
Yeah, it's 8.
It's 8. Yeah. Now the square root of x to the 6th, a couple of ways to do this. Do you remember what you did in class? Can you tell me how you guys approached this problem?
We didn't get to the problem, or like she kind of went over it, but it was didn't
Okay,
really.
so let's draw an analogy here to the numbers. Do it a couple of ways. You can decide what you like. 64 is 8 times 8. Do you see that? And they're the same.
Yeah.
That's why this becomes just 8. So the x to the 6th is really x cubed times x cubed, because when the bases are the same, you add up the exponents. Using the same logic on the left as on the right, what would this on the right reduce to?
Um, it's x to the 6th.
That's the original. We can't be the original. See how 8's
Oh
not the
yeah.
original? See how there were a pair of 8's here and only one
Yeah.
came out, or the one came out? What do you have here? What do you have a pair of?
X to the 3rd.
So
Oh, yeah.
that's what would come out.
Okay.
So the answer is 8x cubed here. We should spend a little more time talking about this. So let's say I asked you to do the square root of 100 x to the 4th. Okay, something like this. So this is really the square root of 100 times the square root of x to the 4th. What is the square root of 100?
10.
10. Now again, it's really because it's the square root of 10 times 10 that gets you to 10. Okay. The square root of x to the 4th is really the square root of x squared times x squared. What would that reduce to?
Just x squared.
X squared. Yeah. Okay. Now, what do you notice about squared compared to the 4? How do you go from 4 to 2?
It's divided by 2.
That's right. Does that same thing apply here? Does 6 go to 3? Is that division by 2?
Yeah.
Yes. Now the reason that is the square root is really to the 1/2 power. Okay, so here's the other way to do a problem like this. The square root of x to the 4th is really x to the 4th to the 1/2 power. And the rule here, when you have two exponents, is you multiply them. And that's why it becomes x squared.
Okay, that makes sense.
So what you'll maybe get here in the future, this is just another example, is something more complicated. Like it'll be like the square root of 400 x to the 18th, y to the 6th. And this is really three problems in one. It's the square root of 400, the square root of x to the 18th, and the square root of y to the 6th. Okay. So in the case of the square root of 400, you know how to do that. You're going to use this 1/2 idea for the next two. So can you tell me what the final answer is here after working this out?
All right. I got 20 x to the 9th and y to the 3rd.
Good. Very good. Okay. So this approach of dividing it by 2 works really well until you get to one that does not divide by 2, and that's where we're going with example 12. So again, this is like the previous problem. It's really the square root of 12 times the square root of x to the 9th. I'd like you to first break apart the square root of 12 for us, then we'll talk about how to do this next one.
I got 2 times square root of 3.
Good. Now, a lot of math really is turning something you don't know into something you do know. Do you agree that x to the 9th is x to the 8th times x to the 1 power?
Yeah.
Now, we do that because when you break these apart, now all of a sudden this x to the 8th is good because you know how to reduce it. What does square root of x to the 8th become? This is what we were doing in the previous problem.
Okay. It's not a perfect square root.
This one is. Square root of 8 is. X to the 8th is.
Oh yeah, it's 4.
It's x to
I'm
the
thinking
4th.
of
Lots of things to mix up, so just take your time here. So notice there are parts that are inside and outside the root. So you match up the things that are outside, 2x to the 4th, square root of the things that are inside, which is 3x.
okay.
Questions? We're gonna do another
No.
one. We'll do another one here.
Yeah.
Okay. Square root of 40 x to the 7th. So again, you break this apart into the square root of 40 times the square root of x to the 7th. So I'd like you to reduce the square root of 40 since
We got two times the square root of 10.
okay, that's good. Now the square root of x to the 7th, you always go down by 1. So we're going to look at this as square root of x to the 6th times x to the 1. And then square root of x to the 6 times the square root of x. You just break it apart until you get something you do know how to do.
So that'd be
What does that become?
x to the 3rd.
Good. And then the last part here is to combine the parts that are outside the roots and the parts inside the roots. So you got 2x cubed square root 10x.
All right.
So let me give you one here to try on your own. Let's say it's the square root of 50x to the 13th power. Go ahead and work that out on your own, please.
All right. Wait, so with 50, it's not where you can keep dividing the number by 2. It's
That's
when you
right.
get to 25.
Yeah, so you try 3. 3 doesn't work. What's the next prime number after 3?
Oh, 5.
5. So try 5. There you go. Keep going.
All right.
How are you doing on this one?
Um, something, I have 10x to the 6th times the square root of 5x.
2x. 2x.
Oh,
Sorry. Yeah. So okay, I think so. In the maybe the root, because the root part may be 3 off here. You bring the 5 out and the 2 stays in.
yeah, I came across that and I took a shot in the dark. I was like, I think this is what it means. And I ended up being wrong.
Yeah. Chances are we'll end up doing more root stuff on Thursday, so we'll leave it there and we'll just make sure we get through this last one. Example 13. So 13 is disguised as one of the other problems we've already done. So the thing to remember here is one of the rules we've already looked at, which is the square root of a times the square root of b is the square root of a times b. So you're going to square root this by multiplying 2 times 10 and a cubed times a to the 5th. So 2 times 10 is 20. A cubed and a to the 5th is a to the 8th power. So from here, this is a problem you now know how to work out. You've been
Yeah.
so go ahead and give this one a try from here, please.
Okay. I have 2 times the square root of 5
Where does the a go? Or are you still working on that?
um, 2a to the 4th.
Yeah, 2a to the 4th square root of 5.
Okay, I was kind of having confusion on where I should put that in the equation.
Yeah, always the stuff that's outside the root goes together, and then the stuff inside the root
Okay,
stays
I should write
inside
that
together.
down. Okay.
Okay, so just to kind of summarize, we'll just do a couple of other problems. let's say I asked you for the square root of 96. Again, as a reminder, it's 2 and 48, 2 and 24, 2 and 12, 2 and 6, 2 and 3. It's you got to look for pairs, right? So there can be more than one pair, but for each pair you bring a number out. Okay. So in this case, you're going to bring out 2 2s and you multiply those on the way out. And then whatever's left stays on the inside. So this becomes 4 square root of 6.
Yeah,
Is that okay?
makes sense.
But not everything works out. Like the square root of 30 actually doesn't work out. It's 2 times 15, 3 times 5. Are there any pairs?
No.
So this is just the square root of 30. So sometimes it doesn't work. And then the last, again, the last thought here is that the square root of x to an even number, like the square root of x to the 8th, this works out nicely, but when they're odd, they do not. So we will stop right there for today and pick up here